Yes, sir, you're audible, sir.
And you're able to see my screen?
Yes, sir.
Okay, thank you. So, good afternoon, everyone. So, we have the 11th session today, and we'll continue from where we left off in the last session. So, this is what we are building, and we'll build in the next few sessions as well. So, in the last session, we started talking about the overall genre of shooting games and how are what different types of shooting games are there, like first person shooters and third person shooters, top down shooters, and basically how all the different shooter games just differ in camera angle placements. And then we looked at some assets in Unity, some new things in Unity, which was a new starter asset pack. We also looked at the old standard assets pack. So we saw that assets pack in Unity, the new starter assets pack is basically like a first person and a third person character scene movement pack, and it gives us the ability to basically start these two kinds of to set up these two kinds of views quite quickly in the game. And next we saw how the starter assets pack is using the new input system, and we changed the input system in our game from the old system to the new system. And we saw how that impacted and how different kinds of inputs are taken. And through the new input system, how we do the exact same thing that we were doing before for movement, but how the new input system is action based and not device based. We looked at, so let me go there. So we looked at these input uh, input actions, how key bindings are defined. We looked at these, and then basically we looked at how these key bindings are called in script. What are the different ways that we can use that? Like we saw here, the player input, how this was being called, and we saw some of the default scripts and how they have been made till now to basically use this. And if time permits, we'll have a separate session just on the input system in a more detailed way, maybe just a half an hour session or 40-45 minute session on just the input system separately to actually understand all the specific parts separately and trying to build the whole system that the starter assets provide us. At least a basic version of this, because this provides us a lot of things. So yeah, and then we uh, looked at something called as Mixamo, where we basically saw how we can import a 3D character, which was this one, and change the starter asset 3D character that was supplied to us, change that and uh, add a new our own 3D model, and it still animates and everything works according to the uh, actual setup that was created initially. For movement, everything works as it should, like uh, how we would want it. For the third person character, what we would want. So everything, so this is where till where we had set up the things. And now next, what we want to do is uh, like it's mentioned here. So we'll look at this were things that we wanted to see in the last session. Well, we'll continue from there. So 3D sound. So it's just a small thing. And then we look at coroutines, and then we look at raycasting. Raycasting we'll be using for shooting. But before we move on from this, there's one more aspect of um, the starter assets that I want to show you, which is like if you remember the rollerball game that we created, we used a package. I forgot the name of the package, but we used an asset from the asset store, which was basically a joystick package for touchscreens. And if you have built your games from that, you'll see that it works flawlessly and very perfectly from that. So that is something that the starter assets also provide us uh, in the form of in mobile based UI. So this basically we'll see in the starter assets folder. Inside the mobile folder, there's a prefabs folder. In this, there are two folders that we need. One is canvas input. In this, there are two types of canvas input. One is UI canvas inputs joystick, and one is UI canvas inputs touchscreen touch zones. So what's the difference between these two? We'll just see. And then apart from the prefabs folder, we also need this event systems. So if you remember, whenever we add a canvas in our system, we need a U event system is created by default for us. So if you remember, if we add something like this, an event system is created for us. So since we don't want this, and since we're going to add the canvas from prefab, that's why a prefab for the event system has also been created. So let's first add that. And this is the event system, which corresponds to the new input system basically. So this is if you look at the old input system event system, it will be a bit different. But for the new input system, this is how it is. And then basically let's take a look at this one. So I put in the UI canvas starter assets pack input joystick. It's not showing up here, but it'll show up in the game menu. And just one more thing is required in the UI canvas controller. We need to define the on which character do we want this to be implemented. So because right now we are in 3D third person mode, so we use the player amateur. This is our character that we want the input to be applied on. And then let's go in play mode. So it won't work in this game view because my mouse gets disabled, and because I'm adding using the input system, I'll still be able to move through keyboard and everything, mouse and everything. But if I have go to game view and change it to simulator, and here I'm able to simulate any mobile device. So Apple, Samsung, Xiaomi, anything, right? So let's go with a random device. And then basically here you see that I'll be able to move using this. So I'm just simulating how it will feel like on a mobile device. And then this is to move around. This is a bit sensitive in this one in the simulator, but works as it should uh, in the actual mobile device. And then we have this one is the jump button, and this is the sprint button. So if I keep pressing this and I'm running through keyboard right now because I'll have to move this as well as keep pressing this. If you remember, so this is running. So this is how you know that this is work. And similarly, if I delete this and use the touch zones one. So touch zones is basically uh, if basically you can press in zones instead of pressing at a specific on a specific button. So you have a big zone in which you can control it. Again, I need to add the player armature and then play. Now, if I press somewhere in this zone, anywhere in this zone, and I'll be able to move. And this zone is basically for me to view around. Obviously, it's a bit sensitive here, as we can see. And then this for movement, and these two buttons are obviously there. And you can pick and choose from like which buttons. Maybe you don't want the sprint button and the jump button to show up, then you can just turn those off, and you will just have the move and the look around. And if you want to increase the zones, that's also possible. You just need to increase the size of the zone, and that will work for you. So that's it. That's the extra thing that we wanted to discuss. And now what we'll do is basically keep this, go back to our game view. We don't want this, so we'll delete this. And also, so now what we'll do is we'll start with our first person shooter game, and we'll look at some of the small things that we'll uh, learn through that. So like setting up, like look at coroutines, setting it up 3D audio, how those things work. So let's delete our third player character completely. And this level is basically our scene. So we'll keep that. And then let's add if you remember, this is how we add the starter assets controllers, either first person or third person. So we'll add a first person controller. Sorry, I touched on something else. I reset first person controller. So this is what we want. And just a second, started doing some. I think it will be just quicker to restart the game. So just a second. In the meantime, if there are any doubts, uh, the things that we have seen till now in the starter assets, in how characters and animations are taken from exam. Great. So this is where we are at. And in this, what we want to do is see these fans. So right now you don't hear any audio. And what we'll do first, so we'll do two things to learn two things. One is 3D audio we want to learn. And I also wanted to write a script to rotate this fan, but there's already, that script is already present here. So we'll just have a look at that script, how it's rotating. And we'll have a look at how we can add 3D audio to this fan so that when we are moving below it, then only we are able to hear an audio. But if we have crossed that area, then we are not able to listen to the audio here. So that's one thing. And the next thing that we'll do is, you see these lights here, we'll try and make these lights flicker, and through that we'll learn coroutines and how coroutines work. We've already used coroutines once or twice before. So let's get into it. And then we'll also have a look at how to add a gun, and then how to add shooting through uh, raycasting. So that is the whole thing that we'll be doing. And for the next thing, what I want to do is I want These three things are basically responsible for my player movement, and these are my player basically. So I'll make a new empty game object and center it out to 0, 0, 0 and place all these things in this one. So this is my player, and then let's go to the fan and let's add that audio. So if I first click on it, so like if you see, you go back here, if I first click on it, basically it selects the whole level in the hierarchy. But when I once again click on it, then I'm able to select the specific object that I want to select. And if you see that the fan is basically structured, it has two parents. The fan, this one above it is basically just the outer covering. And then we have one more, which is just a game object, which is holding both these things. So if you see, the movement code is only on the fan. Basically, this is why it's able to move this fan. And it's a nice code. It's basically a code which uh, has basically defined how much, it's a generalized code. Let's have a look at it. It's a code where basically you can define which direction you want the object to turn in, and if there's also a movement code there. So there are two values that this code is taking, turn X, turn Y, turn Z. This is, sorry, this is one part. The other part is movement part. So if you remember these two functions, transform.rotate and transform.translate. So rotate is basically to rotate something around the axis, and transform is to translate is to move it. And basically, if you see this one option that it is checking, if world equals to 2, world is also a bool variable which is accessible to us in the inspector. And basically, all it's doing is if the world space is checked true, then the space coordinate space in which this thing changes, in which it rotates and translates, would be the world space. If not, then it will be the space around the local, according to the old its own coordinate system. So we don't really need to change anything, but this is the just the code that is being used to move the fan, to basically rotate the fan. So going back here, and if we can, this is turn X, turn Y, turn Z, is basically just controlling the speed of the fan. And what now we want to do is basically we wanted to add audio and see the audio. So we have already seen this. We have already seen what an audio source is. We have seen applied it in one of the previous games. We've also used audio as based on events through script. So that we won't be doing. We just want to, in this, what we want is to add an audio source and make it such that we are able to listen to the audio source only when we are near that audio source. Otherwise, we don't want to listen to it. So let us bring an asset first. First, we'll bring an asset here. So we'll create a folder, audio, and I already have an audio which I downloaded from a royalty-free audio site. So if you just Google royalty-free game audio, you'll find a lot of good sites, and in that you'll find small chunks, small pieces of game audio like that you generally when you play a game, there's audio like there's some voice like good start, let's go, things like that. So you'll find those audio very easily. And then there are small things like bullet shoot, or when you collect a coin, there's a ting. So all those kinds of sounds are very easily available on these sites, and they are royalty free. So you can use them in your games. You can use them commercially, however you like. So this is an audio that I found. Let's listen to it. It's just a fan. I hope you're able to hear it. volumes I think are a bit weird. It's around here somewhere it starts to decrease, but that's okay for because we just want to try it. And what we want to do, so you see there's one more fan here. So we use this also. So let's select both the fans. So now two fans are selected because every component is same. We are able to access those components together. Then we'll take the fan audio and we'll use it as the audio clip. Now what happens is, and if you see here, if you remember this, play on awake and loop. If you remember this, this was basically what I told you to use for background audio, if you remember. So when I go in play mode now, doesn't matter where I am in the scene, I'll be able to hear the audio. The voice of the audio is very low. For some reason. When I checked it, it wasn't like that. So some next functions that we have to basically go through over here is basically what we want to see is keep high is this one uh, spatial blend, which is basically do you want the sound to be 2D or 3D? So we'll keep it at 3D. Then there's a reverb zone mix. Sorry. And then next we have this spread, which basically for us, we want to keep it at 0. And then we have a custom, how do we want to roll it off? So custom roll off doesn't work properly. What we want is either a linear or a logarithmic roll off to basically make it so that like what we are doing actually we can define a minimum distance and a maximum distance. So this is the distance under which you will be able to hear the audio. Otherwise, you won't hear it. So let us test this one. So right now you are not able to hear any audio. When I move under the fan, you are able to hear it. There's some distortions. The audio clip has different volumes at different times, but you are able to hear it. If I move outside this zone, you're not able to hear it. Same case here. I moved out of that zone and now I move in this zone. So I'm able to hear it. So similarly, obviously you can play around with this roll off. You can have a custom roll off also, but you need to understand how exactly this is working, how to actually, what things are you changing here and how that is affecting there. So you can play around with that. Best is to use, like for this kind of stuff, just use linear or logarithmic roll off and then define a minimum and maximum distance. And that sets you not logarithm. I think I changed something when I did this. I changed the verb zone and I think linear. So linear is what works best without any other changes. So this is what you want, and obviously then you can go ahead and play around with it. So that's it for 3D audio. It's you can play around with the audio source. Try to play around with adding different clips in your entire scene. Like let's say there's a gate opening, gate closing, add an audio there. Something else is happening, add an audio there. Try to look at what priority does. Volume is straightforward. Volume, pitch, these things are straightforward. So try to see what changing these settings actually uh, does to your output, does to your listener. So that was one part. Next, what we would want to do, as I said, we'll take a look at uh, implementing coroutines, and for that, let's use this light bulb here. So if you see again this structure, what we have here is there's a light, which is the parent, and then we have a light, which is just this material, this whole thing basically, the mesh, and then we have a spotlight. So this is what we try and control through a coroutine, and this is what we'll make flickering throughout the scene. So if I turn this off, you see that it the light effect, sorry, goes away a bit, and let me position a bit better. Yeah, so light effect goes away a bit, turns on. But you see this emissive, this element, the white color, this itself is an emissive element. So I want to change this. I'll change this element so that I'm able to more clearly see the light flickering. Because even without this spotlight, this light is still actually an emissive source. So it is still giving out light, which I don't want. So I can change that by coming here. There are two materials if you see. One is a diffuse one material, which is the material of the uh, object, the whole mesh. And then there's a neon material, which is basically this one. So how do I change this? I'll go to mesh renderer and open this, and there are two materials here, neon and diffuse. So I don't want to change diffuse, I want to change the neon one. And I'll take this, and now there's a lot of materials available to me, but there's a material called as glass somewhere here, this one. This is what I'll use. So this makes it look a bit better. And now if I turn on the spotlight, it looks like the light is coming through it only and not anywhere else, right? So now we'll write a code for making this light flicker, and then we'll see how it looks in our game. So let's create a new C# script. But before that, let's create a folder for the scripts. Create a C# script, and let's call it light controller. Use any of this. And right out of it, what we basically need is we want to define a light source. So first we want light, and we can name it light itself. And then we want a start function where we basically access this light component. So light would be equal to get component light. So this script is going to be attached to this spotlight object. And in this spotlight, you see one of the components is light. So this is a variable that we have created to access this light. And then next we'll create a coroutine. So if you remember the keyword that is used to create a coroutine is this keyword enumerator. And we'll call this make light flicker. So this is kind of like a method that you generally write. And if you see here, it's right now showing an error, which is basically saying not all code paths return a value. So if you remember, it's a must for a coroutine to return some value. Generally, this is how a coroutine decides what time it should wait for. So if you remember, we looked at coroutines. So let's do that once more. So coroutine allows you to spread tasks across several frames. In Unity, a coroutine is a method that can pause execution and return control to Unity, but then continue where it left off on the following frame. So what this means is basically what I'm doing here is I'll call this coroutine somewhere, make light flicker. This will take effect for some time. It will pause execution of the frame that was currently running and then go back to the exact place where it left off, while the other things are still ongoing. So this execution will stop where the coroutine is called for this thing, while every other frame, every other function is running as is. But as soon as the as soon as I leave from the coroutine, this is where I use wait for seconds or something like that. As soon as I return from this coroutine, it will start where it left off. So where it started the coroutine basically. So next, what I want is to basically in a wait for some time. So what time would that be? I'll create a yield, return new, wait for seconds. So there are some other functions also. If you see here, wait for end of frame, wait for fixed update, wait for seconds real time, wait until, wait while. So these are different uh, functions, that methods that you can use to set up your return functions in coroutines, and you'll use some of them depending upon your conditions, but most of the time it's going to be wait for seconds, because this is where you generally define a time frame for something to happen. So if you remember, when we were playing a audio clip in the last session, we waited for seconds as long as the audio clip length. So that was the time that we used for in that scenario. In this scenario, we basically use a random function, and we'll create a random function with some variables. So for that, let's create two public variables. So we create a public float min and a max. And then we'll wait for seconds with random.range min and max. And then once this wait is over, what we want to do is we want light dot enabled is equals to not light dot enabled. This is a very cool method of changing the state of a game object. So what it's basically doing is once it's checking if the light is enabled or not. So if, let's say, if this value is true, sorry, it's not checking if the light is true on this side. This is a setter method. This is the right side is the getter method. So if you know setter and getter, you can create functions like this, right? Functions where they either set the value or get the value. So enabled is a function which can both set and get the value. So on the left side, you see the setter. On the right side, you see the getter method. So right side, we are checking if it is enabled or not, whatever it is. So like if it is false, then we are doing not of that, the complement of that. So if it is false, it will turn to true. If it is true, it will turn to false. That's all that's happening. And then we are setting this value true or false on the left hand side using the light dot enable value. So this is a nice way of doing this. And then what we want next is to call this coroutine. So there are two ways that we can call a coroutine. One is this start coroutine, and we'll copy this function's name completely. And this is how you can, one way to start a coroutine. And then there's another way where you basically use the string uh, of the name of the function. So in this, I don't want to use the uh, brackets. I just use the string name of the function. So let's go over what's happening now. I think we change the methods name. I think that will help, because giving a warning, I think light might be a, here's the name, giving some warning, might be a controlled name. So anyway, so let's have a look at what we have done now. We have created a light variable which will store our light from the scenes, which is the spotlight. We'll look at lights again sometime later. we can have a small session of lights as well. There are a few different kinds of lights in Unity, but right now it's just storing a light component. And then we are starting our coroutine. What is our coroutine doing? It's waiting for a random number of seconds. This will define min and max. And then basically it's either if the light is already enabled, then it's disabling it. If it's disabled, then it will enable it. But basically, this is going to happen once, and I want this to keep on happening again and again throughout the entirety of the game. So what I'll do is I'll use a while function, and all I need to pass here is a true value, and then go back here. So this way I'll be able to keep on flickering the light again and again. So I'll use coroutine as a endless loop to make something happen. So now let's go back here to our game and attach this here and define some min and max. Let me define it as 0.1 and 1. And nothing else for us to define. If you want, we can change the color a bit so that it's different from all the other ones. Let's make it bright red. And let's go and play. So now we are able to see that the light is flickering, and that's what we wanted. Similarly, we can apply this thing to a lot of other lights here in the scene, and that way we'll be able to make it a bit more interesting. Right now, the lights inside the room, if you see, is a bit bright, but we can change that in the lighting settings. We'll be able to change that using some light options and stuff. So inside the room, it should not be so bright, but right now it is, but we can change that eventually. So that part is done. I hope everything is clear till now. And next, we'll now add a raycasting script on a gun. So first we'll need to add a gun to our game. And where do we get that model? So I think I have one in my package manager assets. So I have this gun which I'll be using. Let me show it to you on the asset store page. This is a pistol PBR Makarov. It's a pistol similar to the kind that you see in the video that we are using, similar to this one. But what we want is basically a gun which has all the different modules, like all the different parts are separable, where basically we are able to access it. It's a modular gun basically, so that we are able to access different parts of it when we want to animate it. So when we want to use animations, when we want to say press the trigger, then we want to actually see the trigger pressing and the this thing. What I forgot what this is called, but when I import it, we'll be able to see names and stuff. So let's import it. What is it? And I want to attach this to my main camera. So if you see now, basically I have the body, I have the hammer, I have the magazine. Oh, sorry, it's a bit big right now, which we'll change. So if you see, we have all the different components, and this is going to help us when we want to actually uh, animate it. So like when a trigger is pressed, we'll want the hammer to rotate a bit, and then this slider would come back, and that's how animation will happen. So let's change this size of this to be 0.05, 0.05, 0.05, and let's see if maybe we made it too small. And where is our camera? So just so that we are able to see while we are building, we use this one, or better yet, let's change it to this kind of layout where we have more access to both the scene view and the game view so that we are able to see them together properly. And that looks good enough. Sorry. So basically what this is just a representative image. How shooting actually happens would be that we'll have a pointer in the center of the camera, and that pointer will basically throw out a ray. And right now we'll just write code for that, and that pointer will throw out a ray, and then we'll be able to uh, attack or like fire on something. That is one way. The other way is to use projectiles, which is generally not used when it is a first person kind of a shooter kind of a game. Projectiles can be created for, visual effect, but generally you will not see projectiles being used for like uh, actually using it for firing, but you can use it depending on how you want to use it. So for the next some time, because now I don't want to change anything in my level, don't want to accidentally touch again and again here and have this fall open up. So what I'll do is I'll use this function where I just press this one. It's a kind of an index finger pointer on the left of the player on the level. And now wherever I touch, it doesn't matter. I'll not be able to select the layer. So this is a function here, whichever thing that you do not want to accidentally touch, or you just don't want to select it in the scene view, you can just turn it off from here. So next, let's start writing a script uh, for the shooting. But before that, I'll also want to create a shoot point, and that is going to be an empty object. Create empty object inside the camera itself, and this is going to be my shoot point. And I can bring it a bit ahead here, so I can bring it 0.5. So this is going to be it's in the center of the camera, and basically what it'll do is I'll be able to shoot at the center of the screen. So if you see the gun is kind of pointing towards the center of the screen, we can arrange that after we add a crosshair or a point or like a shooting indicator that this is where we are shooting. We can kind of arrange how this looks towards that. So we'll do that in next, but let's add this point. So this is a point that we use for shooting. You added the gun. We can rotate it, manipulate it, but it will move around with our player. And all all the things that we have done is on the main camera. And this we are setting up according to the starter assets that we have, that we are using. But obviously, similar concepts apply whenever you are creating your own character controller or own camera controller, the same concepts will apply. So next, let's start writing the script. And for the script, we'll create a new C# script. Let's call it shoot. Open it up. So the first thing that we want is a raycast hit. This is a structure used to get information back from a raycast. So this hit variable is what will actually store where our raycast has hit, some information about that. So basically what object has it hit and all those kinds of things we'll see. But this object is our most important object while creating a raycast. This is where all the information will be stored. Then we'll create some functions and some variables which are essential to the functioning of a uh, in a sense of a gun. So we'll add a variable integer and we'll call it current ammo. So whenever you shoot, your ammo should go down. And then we want a public transform. This is going to be the shooting point. And then we'll have some variables for a rate of fire, which basically defines like once you've uh, pressed one bullet, excuse me, once you've pressed your fire button and shot one bullet, how do you basically, after what time do you shoot the next one? So this is how we'll define the rate of fire. It's a very common concept, rate of fire, which is often used at various locations, various places, when defining where, like things like, let's say in VR, you have a controller setup where you are using a raycast controller. So there's in VR also we use raycast thing. So let's say you press something and then you want uh, to be able to select the next thing only after a certain period of time, or you don't want the player to mistakenly touch that thing again. So that is where you use rate of fire kind of thing. And then we have a public load next fire. This will make sense when we write the code below. It has to be 0 when we start. And then we also need to define a range. I've said all these things public. You can also make it private and set it here, but it's better to make it public and access it through the inspector window. One more thing that you can do is basically make it serializable, make it private and make it serializable, because you don't really need to access any of these variables from uh, any other script. You won't need to access the rate of fire, weapon range, these kinds of things. Maybe current ammo you might want to access somewhere in your UI script where you want to show the current rate of ammo. So that sort of thing. So now we'll create a function void shoot, and this is where I will change the name from shoot to on shoot. So why am I doing this? And this I'll take you back to the my player capsule, this thing, input thing. If you remember, if I create any kind of script where basically I'm using this thing, using like using the input system, the new input system, then right now it is set up in such a way that it sends messages. And if I set a shoot function in my asset, this thing, if I create a key binding for shooting, and if I name it shoot, then it will send a message on shoot. So this is the function that I want to be called when I press that button, when I create a key binding, which we'll do now. But before that, let's complete this function, or we are pressed on time. So for now, what we can do is we create that, and next session we'll write the function here. So let's see how to do that. If you remember this, we have already seen all this. So what we'll do is we'll create a new action. In this action, we'll name it shoot. And this is going to be a button type because it's just a button press. And then we need to create a binding for it, which is just going to be mouse and left mouse button. I think there's a more common usage that we can use pointer. Yeah, so pointer, and I'm not able to find it. There's a thing. Did we use it somewhere before? Just a second. We used delta pointer here, and this was for looking around. So anyway, so just let's use the noise pointer mouse and then left button, and it's in the keyboard mouse interaction. So this should work, and just to ensure that it does, save as it. And now what we want to do is we'll see that there's an onShoot method that's created here. So for that, we'll have to add our shoot script on this because if you remember what I told was this messages will be sent on this game object only. So let's do that. Where was my script? And then this I can define a few things. Save it. And on shoot, let's just right now just write something on the screen. Not on the screen, sorry, in the console window, and save it. Go back here. Get above it. Sorry. So current ammo, make it 100. Shoot point, we have this point. Rate of fire 0.3 something. Next fire should be 0. Weapon range should be, let's say, 1000. We'll change this thing later. But for now, all we want to see is if our button press, the key binding that we have created is actually working or not. So it seems to be working, this thing. I don't do collapse. I'll be able to see this. Here only. So shoot is working. So now all I want to do is add the shooting, and that I think we'll continue in the next session. So this is where we stop today. Are there any questions? So fine, next session will most probably be tomorrow itself, but I'll update you by tomorrow morning. Maximum by 11 o'clock. If I do that, then fine. If not, then next session will be day